Okay, so we are going to perform the pH determination tests on the two samples that we put in wells A1 and A2. So the first thing we have to do is label 3 pipettes. The first pipette is labeled ETOH. You probably can't see that, but label one of them ETOH, that stands for ethanol. Then label one of them FeCl3, that's for the iron 3 chloride solution. And then finally label one of them AA for acetic acid. We're going to use the ethanol or ETOH pipette to transfer 10 drops from B1 into A1. So I'm just going to suck up some of that. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, the rest I'm going to squirt back into B1. And now we're going to use the glass stirring rod to mix this for 1 minute. I am going to use my phone to time that, so I'm making sure that I mix it for the right amount of time. So I'm just setting a little timer and stirring. The reason that we need to do it for a full minute is to get as much of it to dissolve in the ethanol as possible. You don't want to cut these steps short.
Remember that while you're doing these experiments, everything that you do, everything that you see should go in your lab notebook. So as you are doing these individual steps, you should be writing those steps down in detail, and anything that you observe, whether it's some change of color, precipitate, bubbling, anything that you see should go in your laboratory notebook.
Yep, thank you for saying that. I am not keeping a notebook at the moment. I'm trying to show you just the experiment, but yes, you should definitely be doing that in your notebook, and we're almost there. A lot of it has not dissolved, but hopefully plenty of it has dissolved. I did put a rather large scoop in there. Okay, so there's my, there we go. All right, so now what we're gonna do is we're gonna touch the end of this stirring rod to some pH paper. So let me first get the pH paper out of its packaging. When you open up your package, you should see the key to know what the pH colors correspond to. And then you'll see a stack of pH paper. Now I will warn you that these white ones on the ends are just covers. They are not actual pH paper. You can pull those off and throw them in the trash. And then you really only need 1 piece of pH paper for today. We want to be conservative with pH paper because it's actually kind of expensive. So I should be able to use 1 piece of pH paper for all the pH tests that I'm doing today. So I'm just going to swirl that one last time, and then I'm going to touch it to the far left. And you can see how you can get a tiny little test by doing it with that method. So we're looking at the color, and I would record that as a pH of 2. I think that looks red enough, but not the dark, dark red of pH 1. So the salicylic acid has a pH of about 2. That's not surprising, it is an acid, and so that seems reasonable. So you would record your observations in your notebook, and then we're going to rinse the stirring rod in order to do the next test. So now we're going to do the acetylsalicylic acid in the same way. We're going to use the ethanol pipette, but we're going to take the ethanol from B2, and we're going to put 10 drops in A2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The rest I'm going to squirt back into B2. And now I'm going to stir this one for a minute. Remember, this is the acetylsalicylic acid, the pure sample that was provided to us. This is the active ingredient in aspirin, and so we should see maybe a slightly different pH than we saw with the salicylic acid. So we're going to make sure that that's stirred really, really well to dissolve as much of it in the ethanol as possible. I did have a smaller sample of the acetylsalicylic acid, so it does appear that more of it is dissolving, which is not surprising. The 2 crystals look almost identical. They're both white, shiny, crystalline. They're almost needle-like. So all of those types of things would be good to put in your notebook, any kind of observations that you can make. And when I'm finished stirring this, I'm just going to go right away to the pH test. So we're almost there, and there's the timer. All right, so I'm going to take that and put it right about there. And if I hold that up, if I can pick it up, there we go. Definitely a different pH. I'm thinking somewhere between 4 and 5. Probably a 4. Looks like the correct pH, so definitely less acidic than the salicylic acid. And the instructions talk about why. The background part of your instructions talk about why there's a difference there. So at least the pH test is showing us that that is consistent.